Shall we go beyond the green and look at things like Anthocyanins, Pubescence, extra-floral Nectaries? If you're interested in more than just what makes your plants green, stick around and let's have a chat. Hi, my name is Memo, this is my channel Houseplantygoodness, and essentially it's a place where I like to geek out about my big passion. You might be able to see some of it behind me, it's tropical houseplants. So today's video is going to be one for the people that want to know a bit more about some of the processes that plants can do. I've actually specifically chosen ones that are relevant to some houseplants, some not so much, but I thought quite interesting to know just in case. This is also the presentation that I did in London for the rare plant market. So I know a lot of you reached out to me over the weeks where it was leading up to the event saying, oh, we'd love to be there. We're either not based in London and can't make it down, or we are in London and we can't come, or we're in different countries entirely and we'd love to be there for this. This might be one that you're going to enjoy because essentially I'll go over the presentation that I gave during that event and talk you through it as if you were there. And for the people that didn't have any clue about this event, hopefully you'll learn something from all the different processes that plants can do and how we can utilize them to kind of supercharge our houseplants. Okay, starting off with me being on this side of the screen because over here I will hopefully in editing, future Memo is gonna hate me, add in the slides on the side here so we can kind of go through it as if I was there live at the event. So as the beginning of the video might have hinted, the title of the presentation was Beyond the Green, looking at things like Anthocyanins, extra-floral nectarines, pubescences, and much, much more. And essentially this is just me talking you through some of the processes that plants have developed over millennia probably in order to adapt to their specific conditions. And if you're really kind of smart and you kind of look at what we're going to be seeing today, you might be able to see about how you can work with your plants and not against them and not against their natural processes, but also how you can utilize some of this information to better handle the care of some of these plants. So without further ado, let's dive into the first topic. So the first overarching topic is going to be something that I've classed as beneath the surface. First thing I want to touch on is windows in leaves, basically, otherwise known as epidermal windows. So as I talked about in London, the easiest example for this is how many of you all have had, possibly the easiest example I can think of, a string of hearts. Not a string of hearts, a string of pearls. Still on the first coffee of the day, do not judge me. So yeah, string of pearls. And you know that dark strip that you had on each one of the pearls? That is a leaf window essentially. And what it does is it helps direct the light into the leaf, and then essentially that light bounces around because it's kind of like a clear gel-like structure. And at least as far as I can tell, it's believed that that helps the plant to better accommodate for higher light levels. Essentially, it helps it control that light so those leaves don't burn to a crisp and don't get a lot of sun stress. We'll come back to sun stress in just a moment. But this is quite an interesting one because it would mean that some of these plants you can put in very high light condition because they are adapted to it. Some notable examples, obviously, we've got the string of pearls, some Haworthias do this as well, and as far as I can tell, some of the Lithops do this as well. And again, it makes sense. Think about where some of these plants originate from and how they've adapted to that locale. The next big thing that I kind of want us all to consider is pseudobulbs and swollen petioles. And good examples of this would be pseudobulbs. Anybody who is into orchids in any way or form probably has come across plants that have got pseudobulbs. So it's usually a bulb-like structure with some leaves coming up the top and it attaches to the rest of the plant. As far as I could tell, it is believed that this structure is there to provide support for the leaves, but also as a water and potentially nutrient store for the plant as a whole. So it's a really good way of kind of squirreling away some of these resources that might be sparse at different times of the year. And you can imagine that this might be an adaptation if you're thinking of some of the orchids. Maybe some of these orchids go dry for longer than they would be comfortable with. This is a good way for them to store some of that moisture, so when they do have those dry periods, and anybody who has seen orchids with pseudobulbs will tell a lot of the times that those pseudobulbs can go really wrinkly, and you can see it's almost like a balloon deflating. And it is that plant utilizing some of that stored moisture as far as I'm aware, but as I said, I think it's also got some nutrients in as well. The other aspect of that is the swollen petioles. And again, probably one of the easiest examples that I can think of to tell you is look at some of your alocasias, your colocaceas, your caladiums. Look at those petioles. And I don't know if anybody, I'm assuming most of us have probably done this at some point. Have you accidentally chopped one of those leaves off at the petiole? Maybe it's dropped down or something dropped on it, and you were able to see the structure inside that petiole. It's got kind of almost like a honeycomb structure, and it's quite empty essentially. It's think of it as there's a green layer of cells surrounding what is maybe kind of tubes of bubble wrap. I think it's the best way that I can describe it. And as far as I'm aware, that either stays entirely empty, so that air itself is causing that rigidity of those petioles, because remember, these plants need to keep those very heavy leaves upright, basically. Or, and I think this might be another thing, is whether or not those petioles will also fill up with water potentially, if there's a reason for that plant to store water or anything along those lines, or maybe it's getting flooded with water. I'm not entirely sure with that one, but it's a very cool structure nonetheless if you look at it. So that is something to bear in mind. And the way that you can utilize some of this information is, I've used the example of alocasias, colocaceas, and caladiums as an example here, but if you see this in any other plant, it means that that plant is adapted for that as well. So that gives you a bit of an indication of maybe what care you need to provide it, or maybe what it's more adapted to. The other very interesting thing that I came across when I was doing the research for this presentation was something called contractile roots. And this, predominantly from what I could see, it tends to be more on some of the succulent side of things. Think again, possibly of things like lithops, or a lot of Haworthias would do this as well. And if I can, I'll add a picture here as well of one of my Haworthias that, is it the truncata? I'm not entirely sure. It's one that has actually got windows in it as well. So unfortunately, I hadn't realized, and I was kept watering it, and I'm just like, why is this like struggling, and why is it wrinkling up? Too much water rotted out all the roots. I let it callus over, and I put it into some new soil mix, and I didn't think the roots were going to come in that early, and I also did not realize that the roots were going to be as thick as they were. So as I said, I'll try and add a picture there, because it surprised me. The roots were almost on par with a lot of the arrows, very thick roots, and anybody who has grown succulents or plants that are more from arid locations, interestingly enough, a lot of the times they tend to have much finer roots. So, which I find really interesting, because like a lot of the times when that happens, it tends to be from places that get an awful lot of water, and plants that are used to a lot of water, think ferns or begonias, where like those roots aren't meant to really dry out. But with a lot of the succulents and cacti, that is different. But yeah, contractile roots are a very interesting structure, because what it will do is it will, essentially what it says, it will contract and bring that entire plant lower down into the soil. And again, you can imagine this is a way of the plant adapting to those really harsh conditions in the sun, in the heat. And it helps them by going slightly lower into the soil, it would help them to do that. And this is why that Haworthia that I'm talking about probably does make sense for it to have it, because it's got those windows at the top, and the more fragile areas, the rest of the leaves are on the side. So if you imagine it kind of pulls it in further down, it means that those external green parts of those leaves aren't getting bashed by the heat and the light, and the only thing that's left is those windows at the very top of the soil level. I think from what I could tell as well, and I'll correct myself at the top there, I think these roots can discontract, expand, potentially is the right word there, and the plant can raise up when there isn't that danger of too much heat or too much sun. So that is really, really cool. Moving on to something that, as far as I'm aware, doesn't exist in an awful lot of houseplants, and I couldn't pinpoint it, but I thought it's interesting to share nonetheless, because this, I think, is considered a tropical plant, and it does happen a lot. The easiest example for this, I think, is something called the walking palm, and I'll add the scientific name at the top as well. But something that most of you maybe haven't heard of is stilt roots. And I'm trying to refresh my memory when I was doing the research for this. And I think the original concept that a lot of the scientists had about this is that it helped raise the actual stem of the plant, or the kind of the trunk of the plant above the soil level in case of flooding. And it meant that that plant was still going to be rooted into whatever media it was already rooted to and let the water flow in underneath it. However, the interesting thing that they have now started to see is that, and this is the walking part potentially that comes in, is with that plant, because it's around a lot of bigger trees, and some of these trees might fall because of old age, because of wind, because of weather, basically, and they might fall onto this plant. And I think what happens is, say for instance, those are the stilt roots, this plant, the tree will fall down on this one, it will almost sacrifice some of these roots here and let that drop and start creating other roots to tap in somewhere else. And it kind of almost sidesteps the fallen tree or plant basically that's fallen onto it, which I think is so cool. It's almost like the plant is actually walking, because I know a lot of plants out there, they talk about walking plants, and yeah, they'll dive their roots in, but it's kind of almost a reason of expansion rather than anything else. But this is an interesting one because it kind of shows not necessarily intelligence, but it shows awareness of the surroundings, and it's just like, oh, this has happened, so I need to do this now to move out of the way. Very cool. And coming into another wider topic now, which is nectaries and protection. And for the people that have been here a while, you'll probably know the first thing that I'm going to be talking about, which is extra-floral nectaries. And this is that kind of clear, syrupy nectar kind of substance that sometimes will be under leaves, on petioles, on a lot of the houseplants that we have. Predominantly, I tend to find that I find this more maybe on my monsteras and my philodendrons. I don't think I have ever seen it on an anthurium, but it can happen to a lot of different plants. And essentially what it is a kind of sugary substance that the plant will secrete, and it kind of calls in the cavalry, it calls in ants. And the ants will protect that plant because it's got its food source there, it's got that sweet nectar, and it will protect the plant from potential pests. Now, and I said this at the London event as well, there is a flip side of this that you need to kind of have some awareness of, because younger aphids will actually, the kind of green small aphids will also poop out something that is a bit like extra-floral nectaries. So it's a very sugary syrup, and that will also bring ants in. The problem that you get then is that the ants will protect the aphids so that nothing kind of comes and disturbs them, because that is their food source, not the plant. So at that point, they are protecting the pest, not the host plant. So just keep in mind, if you're seeing ants, but you're not seeing any sign of aphids, great, your plant is doing exactly what it needs to do. If you are seeing aphids, obviously deal with the aphids. Just quickly before I move on, the biggest example that I can think of as well, barring the kind of philodendrons and monsteras I was talking about, is pipers. And pipers is one of those things that people will worry about, because pipers, if you flip the leaves over, so Piper sylvaticum that a lot of people might have, or Piper crocatum, if you turn it on the other side, on the flip side of the leaf, on the underside of the leaf, you'll see kind of almost like what is ground salt and pepper flakes. And people get really worried, has my plant got any issues with it? No, because that, for that plant, as far as I can tell, is extra-floral nectaries. It just hardens up, so it's never that liquid form that you might get on some other plants. And the black dots are actually oxidized extra-floral nectaries that have hardened off. So because they're exposed to the oxygen, some of them will go black in color, so you get that black and white effect, which I think is great, considering like the situation that pipers are essentially the family or the genus of plants where the pepper, as in peppercorn, plant comes from. So I'm just like, something like a salt and pepper at the back of the plant that is actually the pepper plant. It's so cool. The next thing I want to kind of talk about is something called allelopathy. and I'm hoping I'm pronouncing that right. And essentially you might see this more in some solanums, and hopefully the picture here will have a picture of the Solanum pyrocanthum, and I've had that, mentioned that in one of my weird plant videos. Very, very cool. If you haven't seen one of these, they are related to the tomato plants. You can have this specific type of plant as a house plant year round, and it's got very cool green leaves with some kind of spikes that look flame colored on it. Very cool. But the solanums, they've kind of seen will do this. Also lemongrasses will do this. So I know lemongrass isn't technically something that somebody might be growing as a houseplant, but at the same time, I think there are some places in the world where lemongrass will grow the same way that you would grow a herb. So people might be growing this in their house. And they've noticed both lemongrass and a lot of the solanum family that the allelopathy that they're talking about is essentially these plants are releasing compounds in the form, as far as I can think of, and as far as I'm kind of aware from when I was looking at this, think pheromones. But what this does is it releases these compounds. It might even be in the soil. As I said, it's very little that I was able to find, and some of the stuff that I was finding was so above my pay grade when it came to the scientific terms that I was getting a bit lost. So they do release certain compounds around them, and essentially it suppresses weed growth, which is really cool because essentially what the plant is doing there is ensuring that there isn't going to be competition for resources such as moisture in the soil, nutrients in the soil, or potentially light by having no plants around it, by kind of making sure that it makes it really inhospitable for other plants to be around it. Now, the thing that you can take away from this, however, when you're looking at your house plants, is if you're going to grow something like a solanum, or if you're going to grow something like a lemongrass or any other plant that might exhibit this allelopathy, is possibly don't do companion planting. Don't put other plants in the same soil substrate with them next to it. As I said again, because I'm not entirely sure if it is pheromones, which means that it would be the air around the plant as well. It might be just in the soil, but generally maybe keep these plants separate from your other plants, because if it do exhibit some of this allelopathy, you might be sitting there going, well, why is the other plant like struggling at the moment? I'm doing everything right. It might just be because it's reacting to those compounds from your solanums and from your lemongrasses that are basically telling it, you need to not be here, you need to die, because I need to have all of this to myself, which kind of brutal, but survival of the fittest is what nature does, basically. Another firm favorite is something called endophytic symbiosis. And I say favorite, you probably just like, I've never heard of this before. You have, if you have ever tried or like did any research on mycorrhizal fungi. So this is the relationship that you get with certain fungi, which it generally is within the root structure and within the soil structure of plants, where there is a symbiotic relationship where this fungi will attach to the roots. What the plant does in terms of the symbiosis is provide it with some of the chemicals that it needs to survive. And what the fungi provides to this relationship is that it will help plants better be adapted at periods of drought. Think of it essentially as that they're extending the root system of the plant itself. And it means that it can reach more water, but it also means that when there's moments of drought, the plant doesn't instantly get so stressed because it's got that fungi kind of attached to the roots, and it kind of helps a bit more in that respect. Very, very cool. And as far as I'm aware, a lot of house plants, a lot of the plants that we might have in our collections do quite well with this. I can only talk anecdotally. I haven't done scientific research specifically on this and done like kind of controlled testing, but the plants that I have used mycorrhizal fungi in the past have always done exceptionally well for me. Let's move into something that affects predominantly the one that we're probably going to be seeing this a lot more in is Hoyas. So sun stress and heat stress. Anybody who has owned a Hoya and has put it in too much light will probably know what I mean by this. And this is where the anthocyanins come in. Essentially, what the plant does is release compounds. So if it's a heat stress, it will release compounds in order to make it better adjusted towards that kind of extreme heat level, so it doesn't kind of wither and die. But on the sun side of things, it will release these chemicals that are anthocyanins. I think either release or activate them. I'm not entirely sure with that one. And that is what turns green leaves red. So you can kind of see that they're blushing a lot of the time. So you sometimes get this with succulents. I remember a very dear friend of mine who is of Asian origin, or at least partially from Asian origin. So she had, still does as far as I'm aware, she has got the Crassula ovata, the kind of jade plant or the money plant or whatever people are calling it all over the world. And obviously it's auspicious within her culture, kind of brings good luck. And she's like, I think I've killed it and it's all gone red and pink. And I'm just like, no, it's sun stress. Move it away from as much light as you're giving it. Give it a slightly less light and it should be fine. But essentially think of the anthocyanins as the plant creating its own sunblock in order to kind of stop the plant from getting damaged from that high light level. It makes sense again if plants might be in locations where there is a risk of that happening, they need to be able to react to it. Now, the interesting thing, and for the people that have got plants that they're also into gardening, kind of outdoor gardening, if I'm not mistaken, it's Traculosperma, I'll add the name on the top there. I think it's called star jasmine. So it's a slightly more succulent type of jasmine. I don't think it's actually a jasmine. It's a different kind of genus of plants entirely. But was it Jasminoides, Traculospermum, or Traculospermum jasminoides? Again, jasminoides is because it's reminiscent to jasmine. This is jasmine omia, so like peperomia, it's similar to basically. So the leaves are slightly different than well, actually considerably different than a jasmine plant. They're a lot more succulent, but the blooms look very similar to a jasmine. The difference is they will stay on the plant for a lot longer. If you've never seen this plant or tried this plant and you've always had a bit of like bad luck when it comes to growing jasmine, or you think the blooms go away too fast, try this one out. It can be a bit slower growing, at least I've heard originally that it was faster growing. I don't think it is, but the blooms stay on and they smell very similar to a jasmine for much longer, basically, whilst a lot of the jasmines within a day or two the blooms have dropped. So very cool. But one of the things that this plant does is that during the winter months it keeps all of its leaves, so it is hardy even to like the UK climate, and it then turns its leaves like a deep red. And in the summer those deep red leaves turn to green again. So it's almost the reverse of what we get with Hoyas. So there are different ways that the plants would be doing. I think that might not be anthocyanins in that situation. It might be chemical compounds that are helping it with temperature stresses. So moving into the section of time and movement. And these are all quite intriguing adaptations that some of these plants will have to essentially either move or kind of are relevant to time. So the first thing I want to talk about is the concept of that kind of molecular clock that some of the plants might have. Now, for a lot of you out there that have ever owned something like a calathea or a player plant of any variety, you've experienced this. So what happens at night, the plant will recognize that you're coming into the evening time and it will start moving these leaves. So that is a reaction to kind of being aware of the time. That requires movement. But think about other things. So think about the night blooming jasmine, or a lot of the tropical orchid cactuses, basically what it's called orchid cactuses. A lot of them will bloom at night, and a lot of them will only bloom at night once, basically, and they'll bloom for that night and then drop it down. I did have that one, and I'm pointing out because it used to be above my head. It's now summering outside, which was the fernleaf cactus, and that one had a beautiful bloom. I'll see if I can find some images and add them here as well. Absolutely stunning. And I know people say that it can be quite tricky to get them to bloom indoors, anywhere in the world for that matter. So I was quite fortunate to have seen that. I was really excited and I just went, oh, let's go and have a smell. It must smell divine. It must smell a bit like jasmine. It smelled like boiled cabbage. So that's the other thing that you need to remember. A lot of these plants that will do things like that at night, you need to remember that who they're trying to attract as a pollinator isn't always necessarily going to be bees. If you think about some of the plants, the corpse plants, they are pollinated by flies during the day generally, but they're pollinated by flies. A lot of these night blooming plants are actually pollinated by moths. and also by bats potentially sometimes, some of these plants. So anybody, again, I'm bringing it into the garden situation, anybody that's grown honeysuckle, honeysuckle smells the most intense at nighttime or first thing in the morning, but then doesn't really do very much throughout the day. It's because its pollinators predominantly, what it's trying to attract is moths and not butterflies and bees, basically. So that's why you get that more. Think of your Hoyas as well. Your Hoyas will be in bloom, obviously, for days on end, but the scent, if you've got a scented Hoyas, will be much stronger at night. So that's something that you need to remember, because, and I'll give you an example, very extreme example of this, but say for instance, you're very, very northern, in the northern hemisphere, where you might get some of those, the longest days ever, that kind of almost the entire day is daylight basically, and the winter that you have nighttime all the time. So in places like that, I would imagine night blooming plants will probably only do that at that transitional period, because they're not going to bloom in the summer for you. If the summer is a time when it's daylight all the time, they need that nighttime. It might not be as kind of black and white as that, of kind of saying they might not bloom, but you might not ever get a scent because it will only happen at night. So something to bear in mind. Coming into the really geeky stuff now, so something called CAMs, or crassulation acid metabolism photosynthesis. So this is a photosynthetic process that a lot of plants that are generally desert dwelling, as far as I'm aware of, have kind of created to help them within their extreme conditions. So if you think of the average cactus, where it might be growing, if that cactus is actively photosynthesizing and opening its stomata, so it's these cells on their leaves, essentially the leaves technically in a cactus are the spines, so you'd think of the stem essentially. So opening up these stomata, and stoma in Greek, which is where the word would originate from, means mouth. And it's these cells that open up essentially for transpiration to happen, for kind of gaseous exchange to happen. If you think about high temperatures that some of these desert situations might be getting, if they open up that stomata for to get the gaseous exchanges happening, they will probably they will get evaporation happening from some of the moisture that they've got internally, because it's so hot. So they've developed this mechanism to do that exact thing, but do it at night. So that's really interesting. The anecdote that I kind of said when I was in London with this one is, this is the one thing that people did get right with the whole kind of get plants because it creates more kind of oxygen for your space. Yes, if you're living in the middle of tropical jungle, and I'm not talking about even this many plants, you need a lot more to make a considerable dent. But that part, they used to say, yes, do keep cacti and succulents in your bedroom because they will release their oxygen at night. True. So that is CAMs. CAMs is quite interesting. The next thing that most people have probably seen, but maybe might not know the name for this, is something called phototropism and also geotropism. Again, I've touched on this on another video as well. But phototropism is if you get something like a ficus or any of the plants that you might have near a window, and all of a sudden you see it leaning. Yes, that's also etiolation, but essentially what that plant is doing is moving, it's etiolating because of phototropism. And the phototropism is just that plant trying as hard as it can to reach out towards that light source. So that's why people always will say, if you've got a plant that is kind of leaning because of phototropism, if you've got it near a window, try to do a quarter turn of the pot every time you water. The reason why you're doing a quarter turn instead of like a full turn is because you want to make sure that that plant remains upright and it doesn't start really stressing out by trying to move leaves. So the leaves that were here, if all of a sudden they're at the back and there's nothing here, it could cause issues with kind of photosynthesis as a whole. So moving it slowly around will generally help with that. But yeah, that is phototropism, and it kind of makes sense. I will use the same example that I had on the previous video of scototropism, and a really good example of this would be something like a Monstera deliciosa. A Monstera deliciosa, a lot of people find it really weird because their Monstera might move towards the shade, and they were just like, well, am I getting it too much light? And they will move it into further shade. What that plant is doing is very smart. It's adapted to its environment. So a lot of the times a Monstera, if it's on the kind of forest floor, it will move towards the shade because shadier bits mean trees mean tree trunk means they can attach onto the tree trunk and then start going up. And that's why a lot of the times you'll see those leaves start to get bigger because they're getting closer to that light. They can keep the leaves a bit smaller. And again, I'm assuming here, when the leaves become smaller, when it's trying to reach out for something for most plants as well, and you can see if you leave something trailing when it wants to climb, the leaves will get smaller and that kind of growing stem might become longer and longer. That internodal space is because it's putting most of its active energy into growing towards something maybe a bit darker or growing towards something that it can attach and go up. As I said, the obvious example is Monstera deliciosa because a lot of people have noticed this in their own houses. Now, geotropism is kind of closely linked to this. So let me give you a very specific example. Say, for instance, you might have had a plant and the growing stem was here and all of a sudden it snapped or it bent down. And the growing stem is now on top of like the soil and the pot, all the random hand movements. But you might then get some arrow roots potentially tapping in. And then this growing tip won't continue growing that way. It will move upwards and move towards the sky, basically. That is an example of geotropism. Essentially, it looks at kind of gravity as far as things scientists are aware of, and it will go, okay, our roots always need to be down, even though we're now in a different position, and our stem needs to be growing upwards, not longwise. So that's why it will go up, basically. And closely linked to this is something called thigmotropism. Nice long ancient Greek word origins here. And that is when a plant will move to avoid touch, potentially. So again, I'll use a similar example that I've done in the past is, say for instance, I sit here all day and start tapping that Esmeraldense leaf. What that plant will do very soon after that, because it's causing it stress at that point, it will try to move that leaf away because it's realizing that something that wasn't there before now is there and it's constantly touching it. So plants are quite smart and they're spatially aware in that respect to kind of move out of something that might eventually cause them harm. And then we come on to the kind of most obvious example of kind of movement within plants, and it's something called Nastic Movement. And Nastic Movement is an example of these. That's probably going to be the easiest way that you can kind of visualize it. Think of a Venus flytrap. Think of the Mimosa pudica, so the sensitive plant. And it is that plant's reaction to a touch stimuli. So similar to thigmotropism, basically. So with this, it might be that, you know, the Venus flytrap will close its leaves and capture the fly. The Mimosa pudica, the sensitive plant, will again close up its leaves because it's kind of aware. But the difference with this is the Nastic movement tends to be a lot faster. What I was talking about before with thigmotropism is that will take as long as it takes for that leaf to move, because plants do move, but they move very slowly. With Nastic movement, as far as I can understand, the difference is that is a lot faster. There's not an awful lot of plants in nature that do this, so people have been studying them for a very long time. So that is something to remember. The same thing goes as well, and this is probably, I don't know whether or not people are aware of this. If you go to a plant store and they've got the sensitive plant or the Mimosa pudica, they always keep telling you don't touch the plant, because actually if they have, usually children, not knowing and not intending anything bad by it, keep touching it because it does something. But what a lot of the times, if you've owned anything like a sensitive plant, and I used to a while back, and it gave me no end of joy because I'm like a 5-year-old really, that plant, the more you touch it in the same place, eventually it kind of not loses interest, but it then realizes that it's, I'm expelling all of this energy. I'm expelling a lot of energy to be able to move that really quickly, but nothing is happening to me. I'm not being eaten. So actually that specific touch, when it happens in that way, is not dangerous. So I'm not going to respond to it. So there is that as well to remember. And then we'll look at kind of adaptations that plants have got in terms of living life on the edge. So things like the location where they might be growing. So again, think of those higher altitude plants. Think about plants that might be surviving underwater, or plants that might be exhibiting osmostress. And osmostress is generally plants, their way of being able to keep upright essentially when there is matter of drought or anything like that. So an example of the opposite of that would be the peace lily. Anybody had a peace lily or a Photonia, the dramatic plants? You haven't watered them for a while and they flop down. Oh, woe is me. They're very expressive. So that's why a lot of houseplant owners love them, is because they know I'm just like, oh God, I forgot to water that plant. I need to water the plant now, and it will perk up as well. So that is an example of the opposite of that. So osmostress would be plants that can actually cope with that period of drought without completely falling apart, essentially. So looking at some of the adaptations and survival to some of these things. So one of them that a lot of people might experience a lot of the times is tends to be more with the alocasias, colocaceas, caladiums. I don't think I've ever seen this one, but it might also happen there, which is something called guttation. And you might see at the very tip of a leaf, and you might see a drop of what looks like water there. That is actually the plant's way of being able to equalize. Yeah, equalize when it's had like an influx of water really suddenly, or it's sucked up water really, really quickly, and it's kind of releasing some of that pressure by releasing that moisture and releasing some of those minerals on that leaf tip as well. You might also, and similar kind of vein to this, is something called hydrothodes. And this is where there are structures on the leaf that will also push out water on the leaf as well, again, to help minimize that stress that's being caused. And it also might help with fungal infection, at least that's what people are considering here. And it's slightly dissimilar, I think, to the stomata. It might even happen from the stomata, but I haven't dived into it deep enough. But it's very cool because that might be when you get like pools of water that are happening on top of the leaf, even though there's been no water around for a while. And then coming into everybody's favorite, the hydrophobic and the hydrophilic leaves as well. So think about your velvety leaves. So I've got the melanochrysum that's looking very tired at the back there, but something that's a velvety leaf. Have you ever sprayed some water on it, and have you seen that the water beads on top of that velvetiness and just slides off? Those leaves are hydrophobic for a reason. This is the plant's way of being able to adapt to being in wet conditions a lot of the times, and being able for them to control their moisture levels. Obviously, if it's hydrophilic, it means that if water goes in, those plants will suck it up. The easiest example that I can think of with this, and this is a garden plant as well, has anybody got hydrangeas? And there is an old wives' tale, and it does work as far as I'm aware, is if you've got hydrangea blooms, cut blooms, and they look a bit sad and they look a bit like dehydrated, yes, you can top up their water in the vase that they're in, but you can also submerge the entire kind of blooms with the stems and everything in water, and those essentially what everybody considers to be their blooms, it isn't. It's kind of almost a bit like bracts, essentially. It's colorful, kind of adapted leaves, and the actual bloom is right in the middle of that, basically. But those absorb moisture, so they're hydrophilic. And it's another way of those plants being able to get and control how much water and moisture they want. And you know, I had to end on one of my favorites. So plant pubescence. And again, apologies to the people that have been around. We have talked about this before, but this is hairy or fuzzy plants. An easy example of this that maybe a lot of people might have noticed is something like a Philodendron verrucosum, where you get those hair-like structures on the petioles. You might get it on other plants as well that are fuzzy. This is the way, at least from what I can tell, the scientists are assuming that the reason why they're doing this is so that they can better control their environment, usually to do with light, possibly some moisture loss as well. So they can control moisture loss, and they can also control the light level that is leaving that's kind of falling onto the leaves. So possibly a really kind of grim example here is if you think of some of the gentlemen that might be on the beach that are very, very hairy. They almost look like they're wearing a rug across their front and back. It's highly likely that at the end of the summer, if you shaved all of that hair off, you'd see a very pale person underneath, because that light isn't going down onto their skin. It's the same thing with having plants that have got that pubescence. It's a way for that plant to be able to control that light level that is reaching down into the foliage. And again, as I said, there are some thoughts of whether or not it's also helping to retain some of that moisture. A good example of this that I said during the event as well. Last year in the UK, we had like an obscenely warm heat wave, more so I think than it's had ever been seen or ever in recent years been seen in the UK. And the example that I gave and people kind of then clocked was most everything that was in gardens and everything outdoors had fried to a crisp in that kind of heat and sun. The lavenders were still going, and lavenders have got a lot of pubescence on them. They were very adapted for when that situation happened to not be really too stressed out about it. So there is something to be said about hairy plants. And all of this essentially coming into kind of some final thoughts, all of this is to say that the natural world is fascinating. There's a lot of different kind of processes and movements or adaptations that a lot of these plants have kind of created for themselves in essence in order to better adapt to their environment. There's obviously like discussion of evolution here as well. So at some point, maybe one of the plants did this and they evolved to prefer that because more of those plants survived. So again, think about the pubescences that we were just talking about now. So the same plant many, many thousands of years ago might have been smooth, but then maybe one came out and it had a genetic mutation that made it slightly hairy, and they had a heat wave and all the ones that weren't hairy had died off, and the only ones that survived were the hairy ones. So by default, it would have evolved to be like, you know what? The hairiness works. Same thing goes for a lot of the other adaptations that we were talking about here. So very, very interesting. And like I always say, try to work with nature. Try to be aware of some of these processes, especially if any of your plants have got some of their own kind of adaptation skills. And if you take that into consideration and you adapt your care to involve some of that as well and not push against it, you are likely to get healthier and happier and probably faster growth as well. But yeah, that's everything I wanted to say. Hopefully you've all enjoyed. Let me know if I've missed anything or if I've made any mistakes in when I was doing my research. More than happy to kind of take the criticism, or if you've got some of your own stories that you want to share down below, I would love, love, love to hear it. But yeah, hopefully I shall see you here soon, and I hope you have a great rest of your day. Thanks. One little side note before we get into the presentation is obviously this was an event where plants were being sold. Guess what I did? So I did control myself and I only got the one plant, but the Anthurium pendens. And this is one that I had seen before. It's been moved quite quickly into a coarse semi-hydro mix. The roots are looking quite good. I'll see how it gets on. Annoyingly, I did it when I got back home last night and I was beyond exhausted, so I forgot to take pictures of the roots. I do have some pictures of the roots within the actual aroid mix, so I'll show you that, not aroid mix, the coarse semi-hydro mix. This is another reason why I'm tired today, but the leaves are feeling quite turgid. So I've got high hopes for these, and any Anthurium generally that I find that's got these long strappy leaves, I mean, behind me with the Terrafolium. I do want to still get the Wendlingerii, and I have come across it and it has come down in price, but it's still quite small and I'd like a big one, but also at the same time now I don't know where I would put it. So this is a bit smaller, so I just went, ooh, yes please. So that was the one purchase. And I said I only bought one plant. That is accurate. I did, however, get a whole ton of kind of growing media. So the people that have been here before and then knew that I did that kind of overview and test with the soil mixes, yeah, 2 bags, and that was because I didn't want to carry too much of the premium soil mix. I think for me, the really telling thing with this soil mix was that I had a lot of other soil mixes, including my own, that I've been using for a while, and I have different bags of different things everywhere. But when I was getting plants in and I was trying to repot, I was gravitating towards this because for me, in my environment that's really, really high in humidity, this tends to dry out quite nicely rather than staying soggy for far too long. So I really rate this, to be fair. And then they also have some sphagnum moss. You can never have enough sphagnum moss, and it's looking very healthy and hydrated and alive as far as I can tell, rather than those kind of bricks of dried up sphagnum moss. And they also had their semi-hydro substrate. So this is really interesting because this looks a bit like crushed up leca, or it also looks like flavum, fluvum, I'll put the name up there. But very cool because I came across it. So I'm just like, you know what? Oh, no, actually, there we go. It is saying that it is fired clay, lava rocks, and osmocote. Very cool. And I want to give this a try and see how it works out. Potentially another experiment is in the works.